This video will be practice problems on derivative of inverse functions. So we're going to apply that weird formula for the derivative of f inverse. You probably don't have it memorized, or if you do, great, but I would suggest that you know how to derive the formula instead of just memorizing it, because honestly, it's way too hard to memorize. It's very detailed. It's like 1 over f prime of f inverse of x, or something like that, if I even remember it correctly. It's way too complicated to remember. So I would suggest you know how to derive it in case you forget, or if you're not even 100% sure. Even I'm me right now, I'm like, is that the formula? Is it not? So I would actually go derive, take 30 seconds, maybe even less than that to derive it. Okay, and if I remember, I'll link the short in which I derived it quickly. And a short is under 1 minute, so you can for sure do it under a minute. Okay, so I'm going to just assume that we have either the formula memorized or we can derive it in these problems. Okay, I'm just going to use them right away. Okay, problem number one. If g of x is 3 times square root of x minus 1 plus 2, find g inverse of 4 without finding g inverse of x. Verify the answer is correct by finding g inverse of x. So this doesn't have anything to do with derivatives yet. So let's go through this first. Okay, so hopefully you tried it first on your own. So to answer the first part, without finding g inverse of x, how are G and G inverse related? Their input and output are swapped. So G inverse of 4 will be some value. Okay. If we plug in that value into G, we will get 4. The input and output are swapped. Okay. So essentially what we want to find is we want, this is the input for G inverse, so we want it to be the output of G. So set this equation equal to 4. That's what I did here. And I called it, instead of X, I called it A. Okay, so A should be 13 over 9 if we do the math. Okay, now to answer the second part, let's find G inverse. How do we do that? We swap the Y and the X. Okay, and then we solve for Y. This is G inverse right here. You can check your work. I'm not going to go through all the steps and the algebra. Therefore, G inverse of 4, we plug in X is 4 into here. We get 13 over 9 as well. So we verified our answer. Okay, number 2, this one requires a calculator. If k of x is 4x cubed plus 2x minus 5, find k inverse prime of 4, or the derivative of k inverse x equals 4. Okay, so we got to apply that formula. What's the formula? K inverse prime of 4 is 1 over k prime of k inverse of 4. See, this is really confusing to memorize because you might think it's k inverse of k prime of 4, or you might remember it correctly as k prime of k inverse of 4. It's just way too complicated. So derive it if you need to. Okay? That's what honestly I would do. I do. I never remember the formula, so I just derive it real quickly. And it's not hard to derive it. Just implicit differentiation chain rule. Okay. So let's find k inverse of 4 first, because we need to find what that is, and then we'll find k prime after that, okay? So k inverse of 4 is like what we did in the other problem. K inverse of 4 will be some value. Let's call it a again. So k of a will be 4. Okay, so we essentially want to set this guy equal to 4, and this is where we need a calculator. X should be about 1.1836. Okay, so k inverse of 4 is 1.1836, okay? So we need k prime as well, because we need k prime of 1.1836. What's k prime? You can use the calculator and derive y1 comma x comma x. You can honestly just do that. Or this one's a polynomial. We can just quickly find it by hand as well. K prime is 12x squared plus 2. So therefore, k inverse prime of 4 is 1 over k prime of k inverse of 4, which is k prime of 1.1836. So we plug in 1.1836 here. That's there. And the final answer should be 0.05316. Problem 3, the graph given is h of x, approximate h inverse prime of 2. Okay, got to use that formula again. H inverse prime of 2 is 1 over h prime of h inverse of 2. Okay, so we need h inverse of 2, which means we are interested in when h of x is 2. When is h of x 2? That's right here, when x is 3. Therefore, h inverse of 2 is 3. Okay? We got to understand and be comfortable with the relationship between h and h inverse. Their input and output are swapped. Their x and y are swapped. Okay? So plugging it into here, we get 1 over h prime of 3. So here was where we got to approximate h prime of 3. What's the slope of the tangent line at x is equal to 3? Over here, if we take this nearby point, looks like the slope is about, is that actually 1? That's 2.5. Did I do this wrong over here? H prime of 3. Why did I say h prime of 3 is approximately 1? Because, oh no, that is right. Because the change in y over change in x is 0.5 over 0.5, which is 1. Yeah, okay. I was confused by the scale of this graph. Okay. So h prime of 3 is approximately 1. So therefore, h inverse prime of 2 is approximately 1 over 1, which is 1. Okay. Problem 4. If m is continuous and differentiable with some values given by the table, evaluate m inverse prime of half. Okay, so hopefully you tried it. Use the formula. It's m prime of m inverse of half. So what's m inverse of half? We're interested in when m is equal to half. That's here. So m inverse of half is -1. Okay, don't get confused with this half over here. Don't pick 2/3. M inverse of half is -1. Okay, swapping the input and output. So the input to m is the output of, or the input of m inverse, sorry, is the output of m. So this is the output right here, this row. So half is here. So that's why m inverse is -1, -1. Okay, so we want m prime of -1. What's m prime of -1? That's right here, -2. So the answer is -half. And that's it for this problem set. All right. So basically, we got to be able to use this formula and understand inverses. Okay. And again, I would highly recommend you go check out that short on how to derive this formula for the derivative of an inverse function as a particular value, or really just the inverse function, if you don't know how to derive it. It's really simple. And we don't have to bother to memorize this formula then. All right. Please give this video a like if you found it helpful in any way. Hopefully see you in another video as well. Bye.